So, good day students, and welcome to the final homework session for this lesson. You will notice that I did not give you anything to read after the theory session. The reason for that is that there are two main aspects on any introduction of biomass into a local or regional energy system. The first thing is the amount of biomass, and the second thing is the fuel quality aspects set by the end user. What you've done in the nuggets in this lesson has mainly been to look at the available raw materials and the end user processes in a quantitative way. So what you shall do now is to widen that scope a bit, and you shall really start to think about biofuel quality and how that may affect the supply system. The aims of this lesson are basically two. First, I want you to fully understand and appreciate that fuel upgrading is by no means as simple as some people will want to tell you. And then I want you to understand a little bit about how to think about these things in real life. The final aim of this course as a whole is to make you a valuable co-worker in any group of planners or engineers setting up a strategy for a sustainable energy system based on a multitude of renewable, local and regional resources. To be able to play that role, you must have the capacity to think critically. So that is what you shall do now. You do have a solid background to fall back on. In the first nugget in this lesson, I do not count the introduction, you looked at several different possibilities to supply two different industrial processes in your region from two different biomass qualities. And you did some simple estimates on how much of these biomasses might be needed, and that was based only on the energy demand by the industries and the heating value of the biomasses. The second nugget then introduced a complication into that simple thinking. So basically you did the same thing again, but now you had to take the energy input into the conversion process into account. So that was to introduce a process cost, a thermodynamic cost, a necessary energy input in the conversion process. After that, you have done three nuggets in which you have basically done the same thing. In each of these nuggets, have you successively mapped the industry in your home region and separated it into three overall categories. First, it's industry that uses light fuel oil or can use a light fuel oil substitute as a substitute fuel. Then you had industry or transports that uses different types of fuel which might be replaced by a relatively low heating value liquid fuel like ethanol, or who might use a more or less clean methane gas. And then there were industries that use coal, heavy fuel oil, or again gas. These industries may perhaps change to torrefied wood, biocrudes, or produce a gas. So you now have a reasonably complete picture of which industries you have in your home region and which fuels they use. When you did that listing, you probably also got a rough insight into which industries use electricity as their main energy carrier. From the first homework, when you used the REST chains training matrix, you have an overall idea of what service can be delivered to the end user from which renewable resources. So you might have an idea in which cases electricity could be replaced by another energy carrier with the end user. And finally, you do know how to estimate the overall efficiency. And then you have read quite a few papers describing the different processes, so you know the basic characteristics of them. So what you shall do now is to make use of all this knowledge that you have gained in the previous nuggets in this lesson. And you shall combine that with what I've said in this nugget in the theory session. And then you shall put together all that into one short essay in which you arrive at one recommendation. So you shall try to sort out all alternatives but one and end up with a recommendation for a single supply chain. Now, you have to remember that depending on how you are taking this course, may there not be any teacher surveillance of how well you solve this task. So you may have to try to raise an argument with yourself. Some questions to ask are, just as example, can you prove that this supply chain is the one that minimizes the biomass consumption and at the same time maximizes the benefits for the end user? To prove minimization of biomass consumption, you will have to compare the total energy efficiency between your alternatives. Another question is, can you prove that the biomass resource you have selected has no use as human or animal food and that the use of it for energy has no negative social or economic impact? To prove that, you will have to think carefully about the biomass selected and the alternative uses. Another thing, can you prove that the upgrading process, which will add expenses to the price the end user has to pay, is absolutely necessary for the industrial process? To prove that, you will have to first understand the industrial process itself. Let me give you an example. Say that there is a cement factory in your region, and say that the kiln is fired using pulverized coal, and say that your suggestion is to introduce torrefied wood pellets as a replacement or maybe just as a complement. Then will your supply chain contain one conversion process, namely pelletizing, and then there will be one upgrading process, namely torrefaction. But if you really understand the cement process and the kiln, then you will also understand that non-torrefied wood pellets will work just as well in coal co-firing. Or another alternative might be to torrefy wood chips. In that case, you would save the expense for the pelletization, but the transport cost would increase. So this is the kind of reasoning that I want you to do. Can you prove that the selected end user, the selected industrial sector, cannot use a smarter biomass feedstock or another conversion process? This is partly the same question as the previous one, but only to some part. Let me use the cement kiln as an example once more. To introduce biofuel into a coal powder fired cement kiln, there are lots of options. You can use torrefied pellets milled together with the coal. You can mill non-torrefied wood pellets milled together with the coal. You can use wood powder, or you could use biogas, or a lot of other fuels. Or, as I mentioned, you can torrefy wood chips and skip the pelletization. Or why not use pulverized straw? So to fully motivate your choice, you must understand which the alternatives are, and you must be prepared to motivate your recommendation. And then remember, this is a masterclass. Since it is, I presume that you have previously done your bachelor degree. So you know how to write an academic report, and you know what scientific thinking means, and that is what you have to apply now. So write down your conclusions and your recommendations in a short report, only a few pages. Do not spend more than one day doing it. That will be enough if you are well prepared and have done the homework in the nuggets. And then, while writing, imagine that your little memorandum shall be handed over to your boss. So document the logics of your reasoning and all your arguments so that you will make a professional impression on your boss. Remember that one very important aspect of such a memorandum is not only to describe the benefits of your recommended supply chain, but also to explain the drawbacks of the alternative ones.